Evaluate 27 to the 2/3. So we first find the cube root of 27, which is 3, and then square it to get 9. Question 2, 16 to the -3/4. First we find the fourth root of 16, which is 2, then raise it to the power of 3, which is 8, and then find the reciprocal of that, which is 1/8. Question 3, write 2 to the 5 times 2 to the -3, and then square all of that and present it as a single power of 2. Well, 2 to the 5 times 2 to the -3 is 2 squared. And squaring that, we get 2 to the 4. Write the square root of 50 minus the square root of 18 in the form of k times the square root of 2. Well, the square root of 50 is 5 root 2, and the square root of 18 is 3 root 2. Therefore, root 50 take root 18 is 5 root 2 take 3 root 2, which is 2 root 2. Rationalize the denominator of 6 over the square root of 3. We must multiply the top and the bottom by the square root of 3. So we get 6 root 3 over 3, which is 2 root 3. Write 1 over 3 take root 2 with a rational denominator. So we have to multiply the top and the bottom by 3 plus root 2. And when we do that, we get 7 on the denominator and 3 plus root 2 on the numerator. Expand and simplify 2 plus the square root of 3, all squared. Okay, so that would be 4 plus 3 to get the first and last. And that would be 7. And then 7 plus 4 root 3. Hello. Solve 9 to the x equals 27. In that case, x is equal to 3. Okay. Simplify 3x squared y, all cubed, over 9x to the 4 times y. Well, we have to do it one letter at a time. So we have 3x squared. So, well, okay, let's handle the coefficients first. So 3 cubed on the numerator, so that's 27, and then 9 on the denominator, bringing us to 3. And then what's the cube of x squared? That is x to the 6. X to the 6 over x to the 4 is x squared. Y cubed over y is y squared. So the final answer is 3x squared y squared. Solve 2 to the x add 1 equals 32. Well, the fifth power of 2 is 32, so x must be 4. Question 11. Write x squared add 6x add 11 in the form x add a all squared plus b. Okay, so we have to complete the square. So you half b, which in this case is 6. So you get x add 3 all squared. But then you have to expand the brackets and check what the constant on the end is. So x add 3 all squared is x squared add 6x add 9. And so to complete the square, we need to add 2. So x add 3 all squared, add 2. Question 12. State the least value of x squared. Take 8x plus 20. Okay, so we need the minimum line, which is minus b over 2a. And in this case, that would be 8 over 2, which is 4. And then we need to substitute 4. So 4 squared, take 8 times 4 is 16, take 32. So minus 16, and then add 20 to get 4. Question 13. How many real roots does 2x squared take 4x add 5 equals 0 have? We need to apply the discriminant, which is b squared minus 4ac, often represented as delta. So in this case, a is 2, b is negative 4, and c is 5. So b squared minus 4ac is 16 minus 40, which is negative 24, which is a negative number, and therefore it has no real roots. Question 14. Find the positive k for which x squared add kx add 9 equals 0 has equal roots. Okay. When does a quadratic have equal roots? When the discriminant is 0. So in this case, the discriminant would be k squared minus 4 times 9. So k squared minus 36. So therefore k is 6. That's the positive value of k. Question 15. Solve 2x squared equals 8x. Now, the temptation is to cancel x here, but you actually lose a solution that way. So instead, bring the 8x to the other side, so you have 2x squared minus 8x. Then factor out 2x. So you have 2x open brackets, x minus 4. And now you can see that x is either 0 or 4. Question 16. Solve x squared minus 5x add 6 equals 0. Okay, this one is... I think it's just x minus 2 times x minus 3 equals 0. And the roots of that are 2 and 3. Question 17. State the vertex of y equals x minus 3 all squared. Take 7. So the vertex of a parabola is that sort of pinching point where it opens up or opens down from. The peak or the trough, basically. Anyway, you have to find the vertex in y equals x minus 3 all squared. Take 7. Alright, so I think you can actually just peel it off, but just to make sure, I'll just square it out, just in case. So x squared minus 6x add 9, take 7. So x squared minus 6x plus 2. X squared minus 6x plus 2. And then apply minus b over 2a. So x squared minus 6x plus 2. X squared minus 6x plus 2. Apply minus b over 2a. So 6 over 2a. So 3. And then substitute in 3. Okay, so we get... Is it just 0, negative 7? Yeah, 0, negative 7. All right. Question 18. Solve x to the 4 minus 5x squared add 4 equals 0. Okay, so first bracket, x squared minus 4. Second bracket, x squared minus 1. But you can apply the difference of two squares to both of these. So you could say x add 2 times x minus 2 times x add 1 times x minus 1. And therefore, the four roots are 2, -2, and 1 and -1. Question 19. Solve 4 to the x minus 5 times 2 to the x, all add 4, times 2 to the x, all add 4, equals 0, equals 0. Okay, so the way to solve this is to recognize that 4 to the x can be written as 2 to the 2x. Yes, 2 to the 2x minus, is that right? No, that's not right. Beg your pardon, beg your pardon. It's 2 squared, all to the power of x. So, there. 2 to the 2x minus 5 times 2 to the x plus 4 equals 0. So set y equals 2 to the x. So then it would be y squared take 5 times y plus 4 equals 0. And then solve like normal. So we get y minus 4 times y minus 1 equals 0. So y is equal to 4 or 1. So 2 to the x equals 4, or 2 to the x equals 1. So x is either 2 or 0. That should be fine. Okay, question 20. Find the values of k for which x squared at kx at 4 equals 0 has no real roots. So you need to apply the discriminant and say b squared minus 4ac is equal to 0. So in this case it would be k squared minus 4 times 4. K squared minus 16 is equal to 0. So k would be the 4 or minus 4. And in question 21, we have to factorize 3x squared, take 10x at 8. This is a non-monic. So we're going to try 3x in the first bracket and x in the next bracket. And then, yes, does this work? Okay, so 3x at 2 times x take 4. Okay, next up, question 22. Solve x at y equals 7 and x take y equals 1. So I'm going to add them together, add the equations together, and I should get 2x equals 8. So x should be 4. And if x is 4, then y is 3. Then y is 3. Question 23. Solve y equals x add 1 together with x squared add y squared equals 25. So the latter equation is a circle centered upon the origin with a radius of 5. And to solve the system of simultaneous equations, we're going to pick up x add 1 and put it where y is. So we get x squared add the square of x add 1 equals 25. So we get 2x squared plus 2x squared minus 24 equals 0. So x squared at x, no wait, oh beg your pardon, I said squared. So 2x squared at 2x take 24 equals 0. So x squared at 2x, x squared at x take 12 equals 0. So x at 4 times x minus 3 is equal to 0. And x is equal to -4 or 3. And if that's true, then y is equal to, all right, so the two solutions are -4 comma -3 and 3 comma 4. 3 comma 4. Next up, question 24. Solve x squared take 4x take 5 is less than 0. So we pretend that it's equal to 0. We pretend it's the equation version. So x squared minus 4x minus 5 equals 0. That's what we're pretending for now. So x minus 5 times x plus 1 is less than 0. So we visualize the number line, and we have solutions at -1, 5, and when does this evaluate as being less than 0? When x is strictly between -1 and 5. Now solve x in question 25. Solve x squared is greater than 9. Alright, so when is x squared greater than 9? When x is greater than 3, or when x is less than -3, under those two conditions. Question 26. Solve 5 take 2x is greater than or equal to 1. So we're going to take 4 from both sides. So we have minus 2x is greater than or equal to minus 4. Then divide both sides by -2. So x is greater than or equal to 2. X is greater than or equal to 2. Next, question 27. Solve 2x squared at x takes 6 is less than or equal to 0. Alright, so we're going to do yeah. 2x take 3 times x add 2. So I know that x is either 3 over 2 or -2. And x must be greater than or equal to -2 and less than or equal to 1.5. Question 28. Find the gradient of the line through 2,5 and 6,13. So we do change in y over change in x. So 13 take 5 over 6 take 2. So 8 over 4 and that's 2. 29. Give the equation of the line of gradient -3 passing through 0, 4. Well, we can say y equals -3x plus c, and then sub in 0, so it would be y equals -3x plus 4. State the gradient of any line perpendicular to 2y equals x at 6. The gradient of any line perpendicular to 2y equals x at 6. Well, this line in the standard slope-intercept form is y equals a half x plus 3. And to get a perpendicular line, or the gradient of a perpendicular line, it would be the negative reciprocal of the gradient of this line. And the negative reciprocal of a half is -2. Find the midpoint of -3, 7 and 5, 1. So you do y1 at y2, x1 at x2 all over 2, comma, y1 at y2 all over 2. So that would be 1, 4. Find the distance between 1, 2 and 5, 5. So you do the change in y squared plus the change in x squared, and then square root the result. And the change in y is 3, and the change in x is 4. So 3 squared at 4 squared, all square rooted. So it would be 5. Find the x-intercepts of 3x at 4y equals 24. So we rearrange and we get 4y equals -3x plus 24. And then y equals -3/4 of x plus 6. And then to find the x-intercept, i.e. where the y-coordinate is equal to 0, you set it equal to 0, set y equal to 0, move the -6, move the 6 to the other side to get -6, and then multiply both sides by -4/3. So -6 multiplied by -4/3 gives us 24 over 3, which is 8. So x would be 8. State the center and radius of x minus 3 all squared plus y at 2 all squared equals 25. The center would be 3, -2, and the radius would be 5. Find the radius of the circle x squared at y squared minus 6x at 8y equals 0. So we have x squared at 6x. So we can do x at 3 all squared plus, oh, beg your pardon, that is actually wrong. X minus 3 all squared plus y plus 4 all squared equals 0. Alright, but then, sorry, we have to actually expand this. We're going to get the terms that we want. So we have 9 there and then 16 there. We have to take those away. So the radius is simply 5. The radius is 5. A diameter has endpoints 1, 2 and 7, 10. So find the center. So the center is the midpoint of the two diametrically opposed points. So it would be 4, 6. Find the gradient of the tangent at 5, 7 to the circle of center 2, 3. Okay. Right, first of all, we need to find the distance between those 2 points. So that distance is 5. All right. Okay. Huh? Okay. And then the gradient from 2,3 to 5,7. So it'd be changing y over changing x. So it'd be 4 over 3. And the negative reciprocal of that is negative 3/4. So yes, there you go. The gradient is negative 3/4. There. Find C for which y equals 2x at C is a tangent to y equals x squared. All right, so I think that would just simply be 0. Simply be 0. Okay, so question 39. Evaluate 5, choose 2. So the row for choosing among 5 elements in Pascal's triangle is the one that starts 1, 5, 10, 10, 5, 1. And 5 choose 2 would be 10. It would just simply be 10. Find the coefficient of x squared in 1 add x all to the power of 6. All right, so mhm. 6. Okay, the 1 doesn't actually matter. One, two. 6 choose. And 6 choose 2. So 1, 6, 15. So 15. It should be 15. 15. Question 41. Find the coefficient of x cubed in 1 add 2x all to the 5. So 5 choose 3, whatever that happens to be. 1, 5, 10, 10, 5, 1. So it should be 10. So 80x cubed. Okay, question 44. Or rather 42. Find the coefficient of x to the 4 in 2 add x all to the 6. 1615. So 60 x to the 4. Find the sum of all the coefficients in the expansion of 1 add 3x all to the 4. You can just straightforward 81, 4, 9, 6, and add them together. So you get 108, 189, 189, add 54, 63. So 252. And 44, find the constant terms in the expansion of x at 2 over x all to the power of 4. No, oh, sorry, I misread it. X at 2 over x all to the power of 4. Should be that one. The central term. 14641. So 6 and square that. So 4, so 24. 24 is the answer. Question 45, evaluate 1 add 2 add 3 all the way up to 20. So we pair 1 with 20, 2 with 19, 3 with 18, and so on until we reach the conclusion that we have 10 pairs of 21, so 210. Question 46, give the exact value of sine of 30 plus cosine of 60. All right, well, sine of 30 is a half, and cosine of 60 is a half as well, and therefore that's 1. Question 47, about give the exact value of cosine 150 degrees. Okay, so that would be minus root 3 over 2. Give the exact value of tan of 240. Okay, so that would be tan of 60, which is root 3. Question 49, solve sine of x equals a half for x ranging from 0 to 360 inclusive. All right, so that would be 30 degrees and 150 degrees. Solve tan of x equals 1 for x between 0 and 360 inclusive. that would be 45 degrees and 225 degrees. Solve 2 times sine of x equals square root of 2 for x trapped between 0 and 180 inclusive. So sine of x equals root 2 over 2. So sine of x, so rather x is equal to 45 degrees or 135 degrees. Solve cosine of x equals -1 for x ranging from 0 to 360 inclusive. All right, so that would be 180 degrees. Simplify 1 take cosine squared of x over sine of x. All right, so using the identity that sine squared x plus cosine squared x equals 1, we have sine squared x over sine of x, so that should simplify simply to sine of x. Given that tan is equal to 3/4 with x being acute, find sine of x. All right, now the literal definition, or rather the triangle-based definition of tan of x is opposite over adjacent. So the opposite is 3 and the adjacent is 4. And now I need to find sine of x. Well, sine of x is opposite over hypotenuse. So that'd be 3 over 5. Question 55. Given that cosine of x is equal to -3/5 with x being obtuse, find sine of x. All right, cosine of x is equal to adjacent over hypotenuse. And if the adjacent is -3 and the hypotenuse is 5, and that's obtuse, all right. Okay, so that's 4. So it should just be 4 over 5. Yeah, I think so, 4 over 5. Question 56, find the area of a triangle with sides 6 and 8 and included angle 30. Does it say right triangle anywhere? No, it doesn't. So maybe when it says included angle, that means the angle between the two sides. In which case we use the area formula, half AB times the sine of C. So half of 6 times 8 times the sine of 30. So half of 6 times 8 times a half. So 48 over 4, so 12. Question 57. Find the third side of a triangle with sides 3 and 4 and the angle 60 degrees between them. So we're going to use the cosine rule. A squared equals b squared plus c. A squared equals b squared plus c squared minus 2bc cos A. So 25 minus 24 times cosine of 60 Cosine of 60 is a half. So minus 12. Minus 12. So 13. 13 is the opposite side. Is the missing side. Question 58. Solve 2 cos squared x plus cos x, take 1 equals 0. For x trapped between 0 and 360. Okay. So if cos x is equal to a half, if cos x is equal to a half, then that means that x is equal to 60 degrees or 300 degrees. And if cos x is equal to minus 1, x is equal to 180 degrees. Question 59, state the period in degrees of y equals sine of 3x. So it should be a third of the ordinary period, so it should be 120 degrees. Question 60. Evaluate log base 2 of 32. So to what power must I raise 2 to get 32? The answer is 5. Next, log base 3 of 1/9. So the answer is -2. Next, log base 2. Oh, log base 2 of x is equal to 5. All right, so in that case, x is equal to 32. Then log base 10 of 4 plus log base 10 of 25. Oh, beg your pardon, that's the ordinary product law. So that's log base 10 of 100, so that should be 2. Next, log base 5 of 100, take log base 5 of 4, so that's log base 5 of 100 over 4, so log base 5 of 25, so just simply 2. Next, 2 times log base 3 of 6, take log base 3 of 4, so that's log base 3 of 36, take log base 3 of 4, so that's log base 3 of 9, so the answer is 2. Next, 5 to the x equals 1 over 25. All right, so x is obviously -2. Now evaluate the natural logarithm of e cubed plus the natural logarithm of 1. Well, that would be 3 plus 0. Now, for y equals 3 times 4 to the x, log y against x is a straight line. So state its intercept. State its y-intercept. Okay, well, the ordinary intercept is 3, isn't it? Yep. So then you just do log of 3. It's simply log of 3, whatever that happens to be. Question 69, differentiate y equals x to the 5, so that would be 5x to the 4. Question 70, find the gradient of y equals 3x squared, take 4x at 7 at x equals 2. So we have to differentiate and get dy by dx, so dy by dx equals 6x, take 4, and then sub in 2, so we get 12, take 4, so we get 8. Differentiate y equals 4 times the square root of x. All right, that would be 2 times x to the minus half. So 2 over root x. Then who's next? Well, who's next is find the gradient of y equals x cubed, take 3x at x equals 2. So you must differentiate. And then sub in 2. So we get 12, take 3, which is 9. And that's the gradient. Next, find the x-coordinate of the stationary point of y equals x squared, take 6x, add 5. The stationary point's the minimum, so we're going to use minus b over 2a. So we're going to use 6 over 2, so that would be 3, and then sub in 3, so we get 9, take 18, and minus 9, and then plus 5, so minus 4. But anyway, they didn't ask for that, so I don't know why I just did all that. It should be, no, I mean, I like it, so it's fine for me, getting the coordinates. Question 75. State the nature of the stationary point of y equals x cubed, take 3x squared at x equals 0. Okay, well, when you sub in 0, you get negative 6 in the second derivative, and therefore therefore it's actually a maximum. Question 76. Find the equation of the tangent to y equals x squared at x equals 3. All right, so we're going to differentiate. So we get y equals 2x. dy by y prime equals 2x. And then we sub in 3, so we get 6. 6 is the gradient. And then to find the y-intercept, we're going to use the known point, which is 3, 9. So we get 9 equals 18 plus c, so c is equal to negative 9, so y equals 6x minus 9. Question 77. Find the gradient of the normal to y equals x squared at 1, 1. All right, so the normal, so y prime equals 2x, and then we sub in 1 and we get 2, and so the gradient is not 2 but rather negative a half. And then we have 1 equals negative a half times 1 plus c. So 1.5. So y equals negative a half x plus 1.5. '78. Find the values of x for which y equals x squared minus 4x is increasing. Oh, we just need to find the minimum. So line of symmetry or symmetry point minus b over 2a. 2, sub that in. Minus 4. X is greater than minus 4. Question 79. Find the limit of x at h all squared. Take x squared over h as h tends to 0. Well, the answer to that would be okay, those cancel out. And we get 2xh. So just 2x. Question 80. Integrate 6x squared with... I appear to have used a whole piece of paper. Amazing. Question 80 says integrate 6x squared with respect to x. So that should be 2x cubed plus c. 81 says integrate x to the minus 2 dx. So we add 1 to the power and then divide by that. So we get minus x to the minus 1 all plus c. So negative 1 over x plus c. Question 82, integrate 3 root x with respect to x. So I'm going to do that. Add 1 to the power, we get 3 over 2 there. And then divide by that new power. That's the same as multiplying by 2/3. So it should be 2 times x to the 3 over 2 plus c. Question 83, evaluate the integral of 2x at 1 from x equals 0 to x equals 3. Three squared at 3, so it's 12. So it should just simply be 12. Question 84, evaluate the integral of x squared from 0 to 3. Z of x cubed. Sub it in. 27 over 3, so 9. 0, so 9. 9 is the answer. Question 85, evaluate the integral of x to the minus 2 from x equals 1 to x equals 2. Add 1 to the power, divide by it. That should be a half. Question 86, find the area under y equals 4 take x squared between x equals negative 2 and x equals 2. Eight take 8 over 3. So that's 8 take 2 and 2/3. 5 1/3. For the upper bound, minus 8. Third for the lower bound, it seems. So should be 10 and 2/3. 10 and 2/3, yeah. Question 87. Given dy by dx equals 2x and the curve passes through 1, 5, find y. Right. So we integrate that dy by dx and we get that, and we know that it passes through 1, 5, so 5. Z is equal to 4, so y equals x squared at 4. Question 88, find the magnitude of 3i take 4j. So applying the Pythagorean theorem, we just simply get that it's 5. Question 89, find the unit vector in the direction of 6i plus 8j. Okay, so applying the Pythagorean theorem again to get the magnitude, we get 36 is 64. Square rooted, we get 10. So 6 over 10i plus 8 over 10j, which is 3/5 I plus 4/5 j. Question 90, given a equals 2i at 3j and b equals I take j, find 2a take b. Three I add 7j. Question 91, find the magnitude of the vector from 1, 2 to 4, 7. Right, the vector three to the right, 4 up, and so the magnitude is obviously 5. Right, question 92. State the vertical asymptote of 1 over x take 2. 1 over x take 2. Now, I know what it would be if it was 1 over x. So all I have to do is shift it 2 to the right. So in that case, it would be x equals 2. X equals 2. Find the x coordinates where y equals x squared meets y equals x at 6. So we have to equate them. So we get x at 6 equals x squared. So x squared take x take 6 equals 0. So x take 3 times x add 2 equals 0. So x is equal to 3 or negative 2. Now question 94, find the remainder when x cubed at 2x squared take 5 is divided by x take 2. Right, so I'm going to do long division. Should be 11. The remainder is 11. The remainder is 11. Okay, state the roots of y. State the roots of y equals x times x minus 2 times x at 3. So the roots are simply 0, 2, and negative 3. Describe the transformation from y equals f of x to y equals f of x minus 2. So that should be a move, a horizontal translation 2 units to the right. Question 97, for which x does y equals x take 1 times x take 4 lie below the x-axis? Okay, that should be between 1 and 4. And now question 98, give a counterexample to if x squared is greater than 4, then x is greater than 2. That's the claim. Well, just simply let x equal negative 3. And in that case, squaring negative 3, you do indeed get that x squared is greater than 4, but x is clearly not greater than 2. Question 99. if n squared at n is always, or rather, question 99, is n squared at n always even for every integer value of n? This is not true, because you can factor out n to get n times n plus 1. And then you choose an even value of n, and you will get an odd value of n plus 1. And, oh no, wait, it actually is always true. It is always true, because even times odd is even, and odd times even is even. Beg your pardon, that's actually true. Yeah. Right, question 100. Give a counterexample to n squared minus n add 11 is prime for all positive integers n. We need only use the 11 times table, 11 itself. So 11 squared take 11 add 11 is just going to be 121, and that's clearly not prime. All right, that's it. Well done. Thank you.